So this is going to be everything you need for IGCSE vectors. Number one, what is a vector? Okay. Everything you've worked with so far in physics, chemistry, and math has been about scalar things or scalar quantities. Scalars are things that are completely defined by just their amount. How much of it is there? Mass, for example, or how much someone weighs, for example, 10 kilos, whatever. Scalars are quantities completely defined by their amount. Defined by amounts. What are vectors then? Vectors are things or quantities. Well, technically you shouldn't say quantities anymore because quantities means amounts. So things defined by amount and direction. So for example, it's not enough for me to say that I'm pushing something with 10 newtons. I have to say I'm pushing something to the right by 10 newtons. Like the direction matters, right? Because if one person is pushing left, the other is pushing right, they are different forces. So vectors are things that are defined by amount and direction. The amount we call magnitude, and the direction we call direction. That's basically it. For example, you can have forces, you can have. My brain is going numb. What other? Velocity, for example, acceleration, for example. All of these things require an amount. How fast am I going and what direction? Which direction am I accelerating in? What direction am I pushing in and by how much? And scalars are like mass, temperature. You don't say it's four degrees upwards. That doesn't make much sense. You would look like a not very smart person. I have to not say rude things because this is a recorded class. So those are scalars and these are vectors. Does the idea stick? Does it like sound like it makes sense?
Mm-hmm.
Right? So there are some things you need direction and amount for. Those are vectors. Now, we already know how to write down scalar things as, mathematical things. It's just numbers. Like mass would be 10 kilograms, of course, but 10, just that number means, a scalar thing. This 10 doesn't have a direction. It's just a number. It's just a magnitude. So how do you write something in mathematics that has a direction and an amount? So we have to get a little bit creative with this. What we do is we create graphical kind of objects. For example, let's say that I can call a force 4, 3. Two numbers. Looks like a coordinate, doesn't it? I mean, coordinates are normally more like this, but this is not exactly a coordinate, but it does ring a bell, right? Two numbers. So of course, one of these numbers implies the horizontal part or horizontal component, we call it. And the other number implies the vertical component. What does that mean? By the way, if something is a vector, we write it in capital letters and put an arrow on it, okay? We can also write a small letters and put an arrow on it. Basically, there needs to be an arrow on the thing, okay? So this arrow implies that it's a vector quantity. It's not just a scalar thing. Now, what does this mean, horizontal component and vertical component? If you look at an XY diagram, a Cartesian axis, basically an XY axis, it'll make sense. A force of 4, 3 vector means there are 4 spaces to the right and 3 spaces upwards. And this is the point, which means that the force is in that direction with this much magnitude. So this is the vector for this force. Okay? So graphically speaking, this is what it looks like. Okay? Now, how do we know how much the force is? Because it is a force, right? Meaning it must have an amount, like 10 newtons, 20 newtons. How much is the force? Basically, what you're asking for is the magnitude. So how do you find the magnitude of this vector? You basically first, this is how you write it. This means magnitude of vector f. Okay, so these two lines mean magnitude. And how do you find it? Just do the horizontal component squared plus the vertical component squared and square root. If you notice carefully, this is essentially the length of this vector. Because you see, if you make a right angle triangle, the horizontal part is 4, the vertical part is 3. Using Pythagoras theorem, this is what the length of that vector would be. Which means that, graphically speaking, a vector's length is its magnitude. Mathematically speaking, this is how you calculate its magnitude. Is this clear?
Yeah.
Okay. So the point that I'm trying to conclude here is that this is how you calculate the magnitude of a vector. I should make the things more general. For example, in general, let's say, if you have a vector, let's call it v for now, and it's xy, the magnitude of v, meaning the amount of v, is simply equal to x squared plus y squared square root. And xy essentially stands for the x component and the y components of the vector. Okay, so the length of the vector in the x direction, the length of the vector in the y direction. You might remember this from physics, by the way. You break down forces into components, don't you? When you have a force, you have to break it down into like a horizontal part and a vertical part, remember?
Oh yeah.
Yeah, so this is basically that. Because forces are vectors, that's why you've been doing that this whole time. Now, normally, we can also find the direction. So remember, we've talked about magnitude, we've talked about the general. By the way, this is called the column vector form. Column, oh, vector form. Okay, because it's a column and it's a vector. It's in one column, right? And this is the graphical representation. These are very self-explanatory definitions. Form, I guess you could call it. So this is how you draw it. This is the column vector form. This is how you calculate the magnitude. But as you can remember, I told you that vectors have a direction. So how do we calculate the direction of a vector? What's the general method? Basically, what we do is we calculate the angle of the vector from the x-axis. Okay, and then we say that this is its basically direction. Okay, so let me show you an example of this kind of situation. Um, let's say that you have a vector right there, and you want to find out the magnitude of this vector. I have the hiccup suddenly. Excuse me. So you want to find out the magnitude of this vector, and you want to find out this angle. As you can see, this is a very basic question if you know trigonometry, right? Even if you know baby trigonometry, this is an easy question because this is a right angle triangle. SOHCAHTOA is all you need, and Pythagoras, of course. So the magnitude will simply be, what is it going to be?
Square root of 4 squared plus 3 squared.
There. 15 plus 9 is 25. Root of 25 is 5. Magnitude is always positive. Never ever write a magnitude as a negative number, okay? Because a magnitude is essentially a scalar quantity. Scalar quantities never get negatives, okay? Now, what about the angle x? How can we find angle x? What do you
Um,
think?
we can
It's a right angle
use,
triangle.
yeah,
Mm-hmm.
um, you can use, what's it called, tan
Okay, tangent
of x will be equal to, um, 4/3.
exactly. And what is x then? How are you
Then
going to
you
calculate?
you put tan -1 and then brackets 4/3.
Tan inverse. We don't call it tan negative, no.
Oh yeah,
So tan inverse of 4 over 3 is equal to 53.1 degrees. So this is what we consider the direction, because there's no other like nice way to say it. So we just find the angle from the x-axis and calculate that and call that the direction of the vector. Okay, but in questions they will make it clear. Now let's talk about addition of vectors. How do you add vectors together? Just a second. So how do you add vectors together?
Like normally, like.
So there's two ways to think about it. The first way is graphically, because we've already talked about two ways to look at vectors in general, right? So first let's talk about the graphical kind of perspective. If you have two vectors, let's say that this is A and this is B, and you want to find out what A plus B is. Okay. What do? You use the head to tail rule, which means that, by the way, vectors don't care where you put them, okay? All a vector is defined by is its horizontal length and its vertical length. Nothing else. No, sorry. I should say that again. All a vector cares about is how long it is and what direction it's pointing in. It doesn't care where you put it. So this vector can be put anywhere, okay? Positions of vectors don't matter. So head to tail rule simply says that to add two vectors, simply attach them in a way that every head is attached to a tail, like this. See, the head of A is attached to the tail of B, correct?
Mm-hmm.
Now, to find A plus B, all you have to do is go from the beginning of A to the end of B. So go from here to here and draw a final vector between the starting and ending point. This blue vector is A plus B. This is the new vector you will get by adding A and B. You see what I mean?
Yeah.
Good. Now, for example, if you have like a more complicated situation, like for example, you have three vectors. This is C and this is B and this is A. And you want to find out A plus B plus C. Again, attach them head to tail. Even the order doesn't matter, by the way. You could have attached C's, like you could have done this instead also if you wanted. See? Because addition doesn't care about the order, does it? So same way in vectors, addition doesn't care about the order. So this vector that we will get ultimately will be the resultant vector. This will be A plus B plus C. Okay?
Mm-hmm.
Because you start at the beginning, go to the end, and that's it. Okay? So this is how you add vectors graphically. We call it the head to tail rule. Okay? Now, thankfully, algebraically, it's easy. Like in the column vector form, basically. Let's actually talk. Okay, so column vector form is like really easy, so let's just quickly touch on it. Column vector addition is simply regular additions. For example, if I tell you that A is 1, 2, and B is like 4, 5, 4, negative 5 even, let's say. You can add A and B by simply adding the top of A to the top of B and so on. So A plus 4, 1 plus 4 is 5 and 2 minus 5 is negative 3, and that's it. That's what A plus B is. Easy peasy. Okay?
Mm-hmm.
You see what I mean with column
Yeah.
vector addition? So this is like graphically you have to do all of that, but algebraically it's this easy. Now, let's talk about multiplying a vector by a scalar number. So what happens if I take a vector and I multiply it by a scalar? Okay? What does that even mean, first of all? It basically means, what if I take a vector like v equals 1, 2, and so 1, 2 looks like this, right? Because you have one step in the right and two steps up. So it'll look something like this, correct?
Yeah.
Right, because one step in the right direction, two steps in the... So what does 2v look like then? 2v will be exactly the same vector, just twice as long. That's how scalar multiplication works. Okay, so it'll be more like this. So it'll be the same exact vector with twice as much of the length, because scalar multiplications only affect the length. Okay, and what does the length of a vector correspond to? Like what is the length of a vector graphically correspond to in terms of like algebraic sense? The magnitude. How much of the, what's the magnitude of the vector? Again, just to clarify, as I said in the very beginning, the length of the vector is essentially the magnitude of the vector, okay? So graphically, in the image form, you will see the vector becoming longer, and in the mathematical form, you will see the value of the magnitude becoming more, okay? Those two things mean the same thing. Is this clear?
Yeah.
Okay. So multiplying by 2 essentially means the magnitude of the vector became twice, okay? So if v is 1, 2, 2v will be 2 times 1, 2, which is, by the way, 2, 4. So scalar multiplication literally just works as the normal algebra. Is this clear?
Yeah.
Now here's the cool part. Let's find the magnitude of v. What is going to be the magnitude of v? This is v, by the way. Leona, can you hear me?
Yeah.
Yeah, so what's the magnitude of v?
Wait, what?
Magnitude of v. How do you calculate the magnitude of a vector?
Wait, now I'm confused.
Magnitude of this magnitude of a vector. You know this. This is the magnitude of a vector. See, it says so. Do you remember this?
Oh, yeah.
So what's the magnitude of v in this case?
I'm going back down.
1 square plus 2 square. Square root. That's it.
Yeah.
Horizontal component squared plus vertical component squared square root. Is this clear now?
Yep.
So it is root of 5 because 1 plus 4 is 5. Now let's do the same thing for the magnitude of 2v. This is 2v. So what is it going to be?
2 squared plus 4 squared. And then root it.
Which is 4 plus 16 square root, which is root of 20, right?
Yeah.
Correct? Okay. Now here's the interesting thing. We can write down root of 20. By the way, do you remember simplifying surds?
Yeah.
So how can I simplify this surd?
You find the highest square number you can multiply
Nice. Very, very
to
good.
get
So
20.
what is it? Start from the smallest square number you know. What's the smallest square number that you know of?
4.
Exactly. So 4 times what?
5.
Is there any other bigger square number that goes into 20?
No.
No. So 5 times 4, which means root of 5 times root of 4, which means 2 times root of 5. As you can see, by multiplying the vector by 2, the magnitude became exactly doubled also. You see what I mean now? The old
Yeah.
magnitude was root 5. Now it's 2 root 5 because you multiplied the vector by the number 2. So the point I'm trying to make is that when you multiply a vector by a scalar, you will essentially end up multiplying its magnitude by that scalar. Okay? So they will stay parallel. They are exactly parallel to each other. They are just longer and shorter versions of each other. Is that clear?
Yeah.
So what have we concluded at this point? We have concluded a very big thing. We have concluded that if two vectors are scalar multiples of each other, they are always parallel. I can't see what I'm writing, so I'll have to zoom in. I hope I didn't make any typos. It looks like I have. Parallel has like 53 L's, I think. 1 second, let me fix that. Oh, forget it. You know what it says. So, this is, by the way, the biggest thing I've said all class. So make sure if you remember anything, I mean, you should remember everything. You make sure you remember this, okay? You're gonna need this in every question that shows up in the final exam. If two vectors are scalar multiples of each other, they will always be parallel to each other. So how do you check if two vectors are parallel? Check if they are scalar multiples of each other. Let me show you an example of this. Are these two vectors parallel to each other? What should you do? Are they parallel? Question mark. Factorize both of them. What's the biggest common factor I can take out of 2, 4?
2,
What's left inside?
1, and then 2,
What's the biggest common factor I can take out of 10, 20?
10,
What's left inside?
1, and 2.
Which means that they are the same vector, just multiplied by different scalar multiples. Which means that this guy is just a smaller version of this guy. They're parallel. You see what I mean? That's literally it. They are parallel. Okay? Is this clear?
Yeah.
Like if you take the vector 1, 2, which looks like this, because you see 1 unit to the right, 2 units up, and you multiply it by 2, you will get this vector, correct? Just twice as
Yeah.
long as that. And if you multiply it by 10, you're going to get something like that. They are parallel, they're just longer versions of each other. Can you tell me now how much longer is this guy than this guy? What's the factor of the, enlargement?
5.
5. Because if you multiply this by 5, you will get that one. Right? Is this clear?
Yeah.
Okay, good. Next up, we have to talk about we've already talked about parallel vectors. We've already talked about multiplying vectors by scalars. We have not talked about multiplying vectors by a negative number, right? What does it mean if I multiply a vector by a negative? So we already talked about how to, like, what happens when you multiply a vector by just a number in general, but multiplying vectors by negative numbers is new still. We haven't discussed that yet. So we know that if you multiply like v, which is like, I don't know, 3, 1, which looks like, 1, 2, 3, 1. So it'll look more like this vector. This is v. Oh God. If you multiply this by 2, you will basically just make it twice as long, right? That's 2v. What happens if you multiply it by -1, for example? What do you think? So this is what the original vector looked like. What do you think will happen if you multiply by a negative number?
Line goes down.
It turns the other way around. It points the other way around. Okay?
Yeah.
If you multiply it by -2v, for example, by -2, what happens then?
Ends downwards.
Yeah, but what else happens? Extends downwards. Exactly, yeah. So don't say it extends downwards because
It
there is no.
doubles.
Sorry?
Doubles.
Yeah, it doubles, but the direction of doubling doesn't really matter. You can place it anywhere. It's just that it points the other way and it's twice as long. Okay? So I could have put it anywhere I wanted. Like I could have put it here, 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 whatever. That doesn't matter. The point is that it doubles in length. So the negative reverses it. It points the other way. This doubles its length. And the v is just, the angle, the vector that you began with. So negative numbers cause a vector to become in the opposite direction. Changes direction. Is this clear?
Mm-hmm.
So that's basically it. And we've already talked about how to add a bunch of vectors together, right?
Yeah.
Like graphically speaking, and also how to do it using numbers. So let's talk about some questions where we're gonna actually calculate some answers. So for example, I give you three vectors here, and I want you to find out the value of p. P is s plus t plus u. How do we do that?
You add um you add 1, 2, and 3,
Exactly.
0,
Mm-hmm. No, no,
and
no.
then
You add 1 to 3, you add,
oh yeah, and then
what is it gonna
add
be?
that
The total of all the horizontal ones. 1 plus 3 minus 2 is
2,
uh 2. And what is the vertical component?
7.
Exactly. So this is your new vector s. You notice that they haven't put any arrows on top, right? Because they're supposed to. Otherwise, I told you that if you don't put arrows on top of your vectors, they are not vectors. You need to specify that s is a vector, it's not just a variable. Okay? So why didn't they put vectors on top? The reason is because they're typing with a keyboard, they can put bold letters.
Yeah.
Okay? So in typed math, bold letters represent vectors, but because you cannot type bold, because you're doing it by hand, you have to put an arrow on top, okay? Do not forget this. You'll lose a point if you don't. Okay?
All right.
So now, try to find out q. S minus 2t minus u. Can you tell me directly what? So actually, let's write it down first. S is 1, 2. Minus 2 times t is this. Minus u is this. Right? Is this clear?
Yeah.
So so the first thing you should do is like regular algebra. Multiply the brackets first. So what is this gonna be?
6,
And
0, and 0.
exactly. So now you have 1, 2 minus 6, 0 minus negative 2, 5. Okay. So now what is q?
So be -7,
Uh-huh.
and then -3.
Negative 7, negative 3? What? Ah, okay, you're telling me the whole answer. Okay. 1 minus 6 is negative 5. Negative 5. By the way, your negative 7 is wrong.
Oh wait, -3.
So you have 1 minus 6, negative 5, and then plus 2, which is negative 3. And now what about the bottom?
-3.
Negative 3. Exactly. So this is how you can mathematically calculate sums of different vectors. And we've already talked about the head to tail rule, right?
Mm-hmm.
Good. So now finally, we can talk about one more thing, which is going to be vector geometry. I will explain it to you in a very simple way. I'm going to use an example to do this. So for example, let's say that you have a parallelogram and it's defined like this. Now, they have told you that the vector AD, so when I say AD, this means the vector starting from A going to D, okay?
Oh
Is this
yeah,
clear?
yeah, I know how to do this. Yeah.
Okay. So let me just explain it for the recording. So AD is defined as vector Y and AB is defined as vector X. Now they're saying, can you tell us what DC is? There's a very easy way to do this. First of all, since this is a parallelogram, remember that any two vectors that are the same length and parallel are the same vectors. Okay? So for example, this vector is y, which means that BC is also y. It has to be, because it's exactly parallel to AD and it's the same length, right? So this vector is also y. Do you agree?
Yes.
Same length and parallel. Similarly, this is also x. Do you agree?
Yep.
Because same length and good. So DC is just x. Easy peasy. What about AC though? Now, to find AC, what you have to do is start at the beginning of AC, which is A, and try to get to C without actually using AC, because you don't know what AC is. That is almost like a game. So you need to travel from A to C without using AC. Okay? So there's two ways. You can either go here and then go here, or you could go here and then go here. Either way, you'll get the same answer. Just make sure that you're recording each vector you pass through. So if you, for example, go through X and then go through Y, you will say X plus Y. Okay? So the answer is X plus Y. That's it. Is this clear?
Yep.
Good. Now, similarly, if I want to find BD, now I have to start from here and somehow end up here, right? I know this is Y, I know this is X. What can I do? Which direction do you want to go in? You have to start at B and go to D somehow.
You go B to A.
Okay. Now, you might think that B to A is X, but no. X is pointing in that direction. So you're going the other way, which means you're going at negative X. Okay? Is this
Yep.
clear?
Mm-hmm.
And then plus Y, because you're going in the direction of Y. And now you're at D, which means this is BD. Got it?
Yeah.
Perfect. Now let's do AE. We need to start at A and somehow end up at E. Okay? Since this is a parallelogram, we know that whatever BD is, BE is half of that. Is this clear?
Mm-hmm.
Like if you know that BD is minus X plus Y, can you tell me what BE will be? So just this part, what is this going to be?
Half of it.
So how do I say that in vector math?
Um, like just put two underneath it.
Yeah, or just, write it like this,
Oh
right?
yeah.
So we're gonna need this for finding AE. In fact, I just realized we already know what AC is. If we know what AC is, and of course we know that these are equal, which means that AE is the half of AC, we can directly say that AE is what? You see it, right? AE is half of AC.
Oh yeah.
Yeah, so what is AE then? You know AC already.
Half of that.
So 1 over 2 x plus y. But remember to put vectors on top, otherwise you'll lose a point. Okay? So this is
Mm-hmm.
what AE is. So this is basically vector geometry. So remember my trick with starting at the beginning and somehow trying to go to the end of that vector. Okay?
Yeah.
Alright, so there are still a few ideas we need to discuss, which are more about parallel vectors and collinear points. I mean, that's just one thing left. We'll talk about that in the next class. For now, I'm gonna leave you with some homework, and that is all. Any questions?
No.
Alright, sounds good.